Welcome to Black Hat Windows Security Conference 2002, held February 7th through the 9th in New Orleans, Louisiana. The following videotape was recorded live at the conference and produced by the Sound of Knowledge Incorporated.
This is Sherief Hammad. Sherief is my lovely assistant, and when we saw someone in half later on, it's no camera trickery or anything like that. It's actual real magic. Oh, wrong talk, sorry. So anyway, we're from Next Generation Security Software, and we like playing with computers. So what are we going to cover? First off, we're going to look at the Oracle Application Server. This deals with the web front end. Runs on Apache. Oracle used to have their own web listener, a product bespoke to themselves, but they believed it was in their best interest and their customers' interest to go with the open source Apache because it was more secure. As we'll see, there are pros and cons for that later on. So we'll be looking at certain vulnerabilities, going on to compromise the web front end. We're then going to introduce the world's smallest Windows shellcode. Well, in my belief it is. Someone please, if I'm wrong, correct me. And then we'll look at the Oracle database server itself and how we go about compromising that. In your packs, you should have the white paper I wrote on this. The fix information is in there. If anybody has any specific questions later on about fixing stuff, then please go ahead and ask. Pretty much, there's a lot to cover, so I'm just going to look at the vulnerabilities for the most part, and then, as I said, in questions we'll cover fixing and stuff like that. So, Oracle Application Server. Where are the vulnerabilities? Well, there's loads of them. Like Internet Information Server, a default install leaves much to be desired. Never take an IIS box and leave it in its default state in a production environment. I recommend do not do the same with Oracle's application server. There are too many defaults, too many samples. Depending upon how you install it, if you do a typical install, SOAP is enabled, and what's more, you can anonymously administer it. Oracle's own implementation of JSP, there are a couple of issues there where we can get access to the translation files. PLSQL packages, that pretty much, PLSQL, it really forms the hub of my talk today. So we'll go over that in greater detail. And then of course, the buffer overflows. Okay, so first off, we'll look at PLSQL. So it stands for Procedural Language / SQL, Structured Query Language. For anybody who is used to Microsoft SQL Server, the best way to imagine PL SQL is like stored procedures. You have packages which are actually stored in the database server, and by the way, I'll explain. This is the client box, this is the web server, this is the database server. PLSQL packages are stored in the database server, and they have procedures which you can execute. They always perform an action. Functions always return a value. To allow PLSQL functionality from the web front end, there is the PLSQL module. So on this server here, as you can see, we're running Apache. Compiled into that is Oracle's closed source PLSQL module. Now essentially that allows us to communicate as a client through the web server to the backend database server and execute inside the database server PLSQL packages, and the results are returned back to us across HTTP. Between here and here, the web server and the database server, it's going over TNS and everything, or SQLnet. So let's look at PLSQL. One of the first things you should know is that by default, you can administer DADs. DADs are database access descriptors. These are used by the PL SQL module to allow communication to take place between the web server and the database server. Essentially, it has things like usernames and passwords. You know, how do we authenticate to the database server? It has TNS connect strings, such as, in this case, we've called it NGS software. That's stored in the tnsnames.ora file, and that file describes how we communicate. So one of the first things to note is that we can actually administer the DAD settings, the database access descriptor settings, anonymously, and there is a default. I've actually changed the default here. It's usually admin underscore, although I've changed it to admin 1. So if I show you here, we have /PLS. That is the location handler set in the Apache http.conf file that says anything leading with a /PLS, pass it off to this module. This handles these kind of requests. Portal 30 is a default DAD. When you install Oracle Application Server, it comes with DADs such as Simple DAD, Sample, Portal 30, Portal 30 SSO, and so on. Portal 30 is one of them. So, as you can see, I basically have access to the settings. Here's the default default database access descriptor is Portal 30. I can go in and edit them, such as this one. You see we're connecting a system. That's a terribly bad thing to do. Password is disguised from us, the Oracle Connect string, just how they're configured. There are a number of buffer overflows in these forms. We'll get to the buffer overflows shortly, but fortunately Oracle has just produced some patches that prevent successful exploitation of them. So, as an example of executing remotely a PLSQL package stored in the database server, there is a package called HTTP. This exports hypertext procedures. You have another package called HTF, which has a load of functions used for producing HTML. For example, if I went http.print !cbuff equals foo, whoop, if I could spell correctly, cbuff equals foo, all it does is simply spit back at what I said. So what I've said is connect to the web server, use the Portal 30 DAD, and that basically goes to a file, wdbsvr.app, looks in there for connection details. The web server then connects to the database server and requests that the database server execute http.print procedure and pass cbuff equals foo as the parameter, and the results are returned. Now obviously there are things like cross-site scripting vulnerabilities here. Let's see, where are we? Data administration. There's cross-site scripting vulnerabilities here. Interestingly though, one of the vulnerabilities with the whole way in which the PL SQL module works is we can actually call functions. For example, sysdate. If I call the sysdate function, which is actually defined on the database server itself, by putting http.p bracket, say sysdate, you can see it's now returned the 8th of February to me. That's bad. I shouldn't be able to execute functions through this. I could call, for example, any of the DBMS packages. DBMS packages are there for the sys or system users to essentially administer the database. As an example, I will use the HTF package with the bold function and then call sysdate as well. So now it's become bold. So you see I'm beginning to execute functions by using http.p, which is obviously short for print. This is something that needs to be addressed. And I only recently found out about it myself the other day. Hence it's not actually in the white paper. I only cover cross-site scripting vulnerabilities in there. So In prior versions, you used to have direct access to a package called OWA_util, and this has many, many dangerous procedures. For example, we can run arbitrary queries with things like the cells print procedure, list print, show query columns, and so on. Oracle, a couple of versions back, actually took the step to prevent direct access to OWA_util. It was still sort of broken because simply by preceding it with like a %0A or %20, which one equates to a space hex encoded and the other a new line character, we could actually break the pattern matching and still gain access to OWA_util. So we could basically essentially run arbitrary queries in the database servers. Again, we've already spoken about DBMS, although I've spelled it incorrectly there. It's not DMBS, it's DBMS. These, as I said, are essentially there for administering the database server itself. If we can access, for example, DBMS job, I can submit jobs that will run at on the database server at a set time. Again, Oracle has now prevented access to them. In the wdb_svr.app file, you have an exclusion list that says only these PL SQL packages are good for this DAD, essentially. So we can reject anything, say in the sys schema, or in any schema we wish, or any specific packages. What's next? This PL SQL module, until recently, had loads of overflows in it. Oracle has just produced a patch on the 6th of February that solves all of these problems. There may be more buffer overflows. I haven't found them, and I hope Oracle has found them all as well. So I'm sure most people in this room know what buffer overflows are anyway. For those that don't, I'll give a quick description. It's essentially, imagine a program that says, please enter your name. It needs an area of memory to store whatever you type in. So the computer program turns around and said, okay, bang, there's a chunk of memory to store the name, whatever the person types. This is called a buffer. Now, if I enter the name David, that fits okay in the buffer. If I enter, like say, let's say the buffer is 100 bytes bigger. If I enter any more than 100 bytes, I'm obviously going to overflow the buffer and overwrite crucial stuff in memory. Now, I'm not going to go into how procedures are called and how save return addresses are pushed on the stack. If you don't know about buffer overflows, there's plenty of good stuff on the internet. Just do a search on Google or something, buffer overflows. Dildog of Loft/@stake fame wrote one of the earliest papers on Windows buffer overflows, a good read, and his haikus are quite interesting as well. So there are, as I said, multiple buffer overflows in the PL SQL module. I could request an overly long help file name. For example, I go to admin1 /help/toc.htm. We can get access to this, providing we know the admin path. The admin path here, by the way, is admin1. The default is admin_. As I said, I've changed it here. Interestingly, if you use access control to prevent people from administering the DAD, they can still get access to these pages anonymously. So it's provided we know the admin path, we can exploit the buffer overrun here where we essentially just add an overly long file name. I'm not going to do it because I don't want to have to shut down and restart my Apache box essentially. We will exploit one of them though. Overly long password in the add dad form. This was what we just looked at a few moments ago. Add dad. If I set an overly long password here in Oracle password where these dots are, that will cause an overflow. Now, interestingly, it will also wipe out your wdb_svr.app file. Because it crashes halfway through writing to it, everything just gets blanked as well. So if someone was to attack you in this particular error, unless you've got a backup of your app file, you're in trouble. Well, you can manually redo it, but it's more of an annoyance. Overly long directory in the cache form. We go to cache.htm. Here, if I set an overly long directory in there, again, there's an overflow. As I said, there's overflows all over the place. If I was to town it into port 80 and say get/pls/foo/ procedure, but then also present the HTTP authorization client header, and with an overly long password in there, again, that will cause the buffer overflow. What's interesting as well is that your exploit code, any exploit code going across, would need to be base 64 encoded. That's not difficult to do, but it will probably bypass a lot of IDS systems because no one ever actually decodes base 64 passwords to see, is this an attack? So it's obfuscation to a certain degree. So we're going to look at shellcode now. What is shellcode? Shellcode essentially is exploit code that will drop me into the equivalent of a command shell. One of these things, we've all seen them. Traditional Windows shellcode is around about 600 to 700 bytes. Essentially what we do is, as part of our exploit code, is turn around to the vulnerable process and say, create this process for me, create a cmd.exe process. We need to create some handles for standard in, standard out, and standard error. In other words, standard in is where you type, standard out is what's thrown back at you at the screen, and again, standard error is what's thrown back out. We create two anonymous pipes basically for inter-process communication. So when I create the process, I use these pipes for standard in and standard out. That is the long way to go around it. As I said, that grows to 600, 700 bytes. We can actually use the WSA socket function, and the socket returned from that, we can actually pass these as handles to the created processes, standard in, standard out, and standard error. So essentially, all we need to do is call WSA startup. Well, actually, we don't even need to do that simply. If the vulnerable program has already called WSA startup at some point in its execution, we don't actually need to do this. But we're not sure whether we're necessarily dealing with a WinSock application on the remote end, so it's probably safer to call WSA startup unless you know you're specifically targeting something that does. We then call WSA socket, pass it to bind and connect, and pass them as handles to create process, and we're down to 174 bytes. Essentially, this is more of a problem now. We can, as I said, we're shrinking it down to 174 bytes, and there has been a number of problems where the overflow is, if you enter too many bytes, the overflow will fail, and so traditional Windows shellcode will not succeed. So now we're down to 174 bytes. It should be a standard easy thing. And this is a remote shell. So what's compromising the web front end? What I've got here is Netcat listening on port 53 on this machine. I'm going to send an overflow string to this machine, the web server, that's going to bind back out to me on my port 53. Now, obviously if there's a firewall in there, in the way that's stopping outbound connections on port 53, this wouldn't work. However, what you can do, and the code actually gets slightly bigger here, is basically say get peer name and essentially try and locate your socket in the socket table. Now, if you call get peer name on your IP address like time after time after time again to try and find your socket handle, it will fail even if you have found the right socket. Essentially what you do is increment the socket handle. That's a bug with Microsoft. It's not a security bug, but it's just the way they've implemented get peer name. So what we have to do is essentially say get peer name, try it, was it our IP address? When we give it, like, try a socket handle of 100. If that fails, call another socket function, for example, socket. Then go back and call get peer name, and it will work if it indeed is your socket. So we can actually do that. So if we connect in over port 80 through the firewall, because let's face it, the firewall is not going to block access. It needs it, you know, for a public website. We can actually bind to that shell. So regardless of the firewall, this is still going to be vulnerable. So what we're going to do here, I've got netcat listening on my port, port 53, send my exploit code, and it's going to reverse shell back out to me and drop me into, we should actually see the Apache process access file, because it's not cleaned up after me. Right. Right. That's gone. And here's my reverse shell. If I do a host name, that's this box here, basically. So this one's called computer name, and this one's called factory install x hyphen blah blah blah. So as you can see, we're in the Oracle iSuites Apache directory. That's the default working directory for Apache. If I say who am I, I'm running as administrator on there. Unfortunately, it's not running as a system service at this point in time, simply because I've just previously brought it down and brought it back up again. But I'm running as administrator, so I can essentially just add my own account, like net user David test password / add. So I've now essentially got an account on here. I can add it to the administrators group, net local group administrators David test / add kind of thing. So here we have compromised the web front end. Yep.
How come we brought down the Apache executable, not this Oracle?
Apache's running on here. Oracle's running on here. It's the PL/SQL module is a DLL that's in the address space of Apache. Sorry. So before we even go anywhere near the database, in the processing of my request, it's access violated, you know, or overflowed it kind of thing. So what I'm going to do here now is kill. Now this might not work. Right. Apache killed. If I then do a net start, I can restart that service, and even though I've still got my reverse shell, I can get back in to the web service. Now we've compromised the web front end. We need to compromise the database server. So we're going to move on to attacking the Oracle database server. So again, PL/SQL seems to be the root of the problem. PL/SQL packages stored in the database can call external procedures. What that essentially means is Oracle have built into the whole PL/SQL environment the ability to call any function in any DLL on this system. Now, normally, you would basically create a library, as in a PL/SQL library, on the database server. So you need those kind of privileges to do a normal attack. I'm going to show you how we don't even need to actually have a user ID or password to actually exploit this functionality. Of course, if you've got the auto-library privileges as a database user, you can again do it as well. So how Oracle external procedures work. We have the Oracle process that communicates with the listener process that says, I've been asked to run this function in this DLL. The listener process then starts xproc. They communicate, and the Oracle process then turns around and says, please load this library. Got a picture thing here. Right, so we have the Oracle process, turns around to the listener on port 1521 and says, please start xproc for me, I need it. So the listener starts the xproc process, and the xproc process is now listening normally on a named pipe, although as we'll see later on, we can actually force it to use sockets. So xproc then tells the listener, hey, I'm ready and waiting. The listener then informs the Oracle process that the xproc is ready and waiting for its bidding. Yep, right. So Oracle then connects to the xproc process and says, please load this library, execute this function, and pass it these parameters. Now, what we can actually do is be a rogue process, whether that is local to the database server or remotely. What we're going to do here is essentially speak to the listener and pretend to be an Oracle process. As long as we're speaking the same language, it should do our bidding just like it did Oracle's bidding. Remember, we need a user ID and password to gain access to, like Oracle. Doing it this way, we don't need to authenticate. So we write an exploit program, the rogue process, that connects to the listener and says, I want to run an external procedure. And obligingly, the listener process starts xproc, and then the listener process tells us where to connect to. So we then directly connect to xproc. So I'm going to do it from this one here for the minute. Oracle or CMD 5 host Damas. Okay, this exploit on this screen here. Essentially, it's please ask me for the command to run. So actually, before we even do that, I'm going to try and authenticate to that machine. We have no shared connection at the moment other than over Oracle. So netuse 199.199.199. You've got the server starting on this, Sherief? C dollar. That's .1, isn't it? Password /user. Right, I'm going to, logon failure, bad username or password, okay? So what I'm now going to do is essentially create that account on this machine so I can then basically access this box. This is to show you the attack in progress. So enter the command to run net user QWERTY password, if I could spell, password /add. Right. Let me use the IP address. It'd be better 199.199.1. Right. What's happening here, if we slow it down, let me scroll it back. This here, we've connected to the listener, and it's told us it's launched the xproc process, and it's listening on. I know it must be difficult to see from back there, but it's listening on port 1035. So we then connect to port 1035. We go through a semblance of authentication, but it's absolutely completely irrelevant. We then set up a number of environment variable kind of things. And then we finally get a response back. Workgroup / his computer name gives us the process ID of xproc and the function we've just called. What I'm essentially doing is saying load msvcrt.dll, call the system function, and pass it this argument, and the argument being net user QWERTY password /add. So now I've got to make that an administrator. Net local group. Is it local group or local groups? Is it a group? Administrators QWERTY /add. So now we try and connect and we get the command completed successfully. So we now essentially own this Oracle box. We've created an administrative account. These commands were running a system, by the way. Oracle by default runs a system, so any command we actually execute, or any function we execute rather, and it just so happens we're executing the system function here that allows us to run commands, will run with full privileges over this computer. So essentially, the computer's owned, we own the data, we own everything on there, which is not a good thing. So essentially, what we've done, wrapping up, is compromised the web front end, and from there, compromised the back-end database server in a couple of easy steps. So I think that's come to the end of this talk, probably perhaps slightly too quickly. Has anybody got any questions?
Have they fixed that one, the lack of authentication?
There is no fix for it. There is a workaround for it. Essentially, it's difficult to, it's not a great fix, but it's the best that can be done. It's so core within the way Oracle works, it would take a major, major rewrite. So in terms of risk mitigation, Oracle chose that they should release an advisory on this issue before this talk because it would look bad otherwise, essentially. Well, in future versions of Oracle, this will no longer be a problem. There are certain workarounds you can do, such as using TCP node valid checking, but essentially, in terms of this kind of attack, it does you no good because the web server must be one of those trusted hosts to communicate with the database server. So there is a workaround. It is about risk mitigation. A patch will be coming eventually.
So the web server needs to be able to make that connection. Now, so you have to own the web server before you can pull off this attack?
Well, if you're behind the firewall, if you can communicate with the listener port, and when XProc is now listening on a random high port, it shows 1035 there. As long as I have direct access to any likely high port that XProc will be listening on and the listener process, then yes, I can do this. Not many people actually need the functionality of calling external procedures from within a PL SQL package. So most people can just basically turn around and just strip it off the system. Any other, Tim?
I was just going to ask, where does Oracle being unbreakable come into play here?
Right. That's obviously a rhetorical question and doesn't warrant an answer. Oracle is committed to security. We all know that, Tim. And you're just stirring now. Oracle product has undergone 14 independent security evaluations, which is at least 13 more than any of its competitors. Hey, look, I don't have to defend them, but I do. I know the Oracle security team. They're a good bunch of people. They are committed to securing their products. Whatever the marketing department and everything like that does are two entirely different things, But it's sort of embarrassing for them. Any other questions? I said to Jennifer Granick earlier on today, you know you've done a good talk when you get loads of questions at the end, so thanks a lot, you guys. Thanks.